To start today, please find the derivative of this function. So when we just plug in the quotient rule, this is what we're looking at. And this is the derivative, but I want us to simplify this. So please simplify this as much as you possibly can. So far I've done the distributing on the top. I like to leave the bottom in factored form because maybe there's something I'll be able to cancel out later. So we got it this far, but it does go even further than this. All right, so at this point, notice that in the top, there's something very useful up here. We have this sine squared plus cosine squared, which is one of those identities that, yes, you should know. What's sine squared plus cosine squared? 1. And so the top is negative sine x plus 1, although we can clean that up a little bit, right? So we aren't starting with the negative sign. So I'm going to write that then as 1 minus sine of x. And that's then all over the 1 minus sine x squared. Well, notice now I have a 1 minus sine x in both my numerator and my denominator, so I can cancel those out, which then leaves me on the top with just a 1 because I canceled everything else out on the top. And on the bottom, I canceled out one of the 1 minus sine x's, but I'm still left with 1 minus sine x. That's then totally done. And so notice there's a lot of simplifying we can do when it comes to trig stuff. That's going to be a bit of a theme today, is actually doing some trig derivatives and simplifying them as much as possible, using what we know about our trigonometry. And so with that in mind, we're going to find the derivative now of tangent of x. All right, so if we're going to find the derivative of this, the very first thing we need to do is we need to write it in terms that we do know how to find the derivative of. Well, we know what tangent equals, right? What does tangent equal?
Sine over cosine.
Yep, it's sine over cosine. So we're going to do sine of x over cosine of x. Now, it's in a form that we can actually work with. So now we can find our derivative. So go from there, go ahead and find the derivative at this point. So when we plug in the quotient rule, this is what we end up with. But of course, we're not going to stop here, right? We can simplify it. And so when we simplify by just multiplying stuff through on the top, we end up here. And once again, we see our favorite trig identity. Sine squared plus cosine squared on the top there. So we know the entire numerator of this fraction then just equals 1. Now on the bottom, we still have our cosine squared of x. But that means that we do have the cosine squared of x there, so then we now know it. This is our derivative of tangent of x. It's going to be 1 over cosine squared of x. All right, now, having done this work, though, every time you see tangent, and you're going to see tangent a lot, we don't really want to have to go through and redo this work every single time, right? And so we're going to want to be able to write this into our notes. But I also don't really want to have to write 1 over cosine squared every time either. What's a shorter way to write 1 over cosine? Secant. And so this then is also secant squared. And so let's add that into our derivative rules now. You may recall that we wrote down our sine and cosine derivatives a week or two ago. And you left 4 lines to be able to add more. Well, this goes on the first of those extra lines. Now that we know these 3, let's keep going. There are, of course, 3 other trig functions that we should know the derivatives of. So your job now is to find the derivative of each of the other 3 and clean them up as much as possible. So we now have this down to our notes, but we are going to have these memorized. So let's talk about some strategies and some patterns in this that we can look for that are going to help us to know it. First of all, you notice some of our derivatives are positive, some of our derivatives are negative here. Let's take a look and see which derivatives are negative as we look through it. what do you notice is true about all of those derivatives that give us negatives? Yeah, any of them that start with the C for the original function. So all of the co-functions, cosine, cosecant, cotangent, all of those give us a negative when we find the derivative. So already we just made it a lot easier to remember, right? And then there's some other little patterns, like you'll notice that between the tangent and the cotangent, those are the ones that give us the squared. Okay? It's just a matter of secant or cosecant. And notice the tangent went with secant, the cotangent went with cosecant, so the cos went together there. All right? What about the cosecant and the secant derivatives? Well, you'll notice both of those derivatives include the original function. Cosecant includes cosecant, and secant includes secant as part of the derivative. It's just the extra little bit of the cotangent in the tangent. But once again, the cos include the cos. So cosecant has its derivative with the cosecant and the cotangent. And the secant is the secant in the tangent, no cos. So no cosecant, no cotangent there. So these are just some hints that you can look for, some ways that you can be memorizing these. Now there's still going to be a little bit of memorization work to do there. And yes, they can be a little bit tricky to get down, but we got a week to get it down. So use some of those hints as well as maybe a few other things to help you get there.